Good morning, dear students. My name is Ferhan Mazher, and today is 16th April 2021. The day is Friday, and now we are studying the subject Physics 5054. It's O levels physics. And today we have set our hearts to solve October-November 2020 2-1 paper. In this session, in this video, we will be solving section A of this paper. The section B of this paper, we have already solved. It's uploaded in my YouTube channel. You can find it there. So today we are going to solve October-November 2020 Physics 5054 2-1 paper. This paper belongs from the Zone 1. So let's start our paper. Okay, so the first question, this is the paper October-November 2020 2-1. So let's start today's paper. Okay, so here on your screen, it's showing that we have figure 1.1 is the distance time graph for a skydiver who jumps from a balloon at time t equals to 0. So this is a distance time graph. The distance time graph, on the y-axis, the distance is given. On the x-axis, the time is given. And distance is in meters, time is in seconds. The first part of the graph shows the motion of the skydiver from when he jumps until he reaches the terminal velocity. Describe the motion of the skydiver between t equals to 0 and t equals to 20 seconds. So he is going to reach the terminal velocity after 20 seconds, and we have to describe the motion. You see, if you look at here and pay attention, you will see. So from T0 till T20 here, you know, the graph is curving. It's curving upward. But here and after 20 has become a straight line. On the distance time graph, the straight line means that the body is moving with the constant. And when it's curving upward, it means that the speed is increasing. And when it's a straight line, inclined straight line like here, it means that the speed is constant. So he wants us to describe the motion of the body from T0 to T20. From T0 to T20, I can show the speed is gradually increasing. Okay, the speed is gradually increasing because the skydiver is having a free fall. So its speed will continue to increase till the time is 20 seconds. But the acceleration, when he will jump at t is equal to 0, his acceleration will be maximum. And because when he will be falling, the air resistance will start acting on him. So his acceleration will decrease. So the acceleration of the body at the start will be maximum, and then it will gradually decrease. After 20 seconds, the acceleration will become 0. And the velocity or the speed of the body that has increased from T0 to T20. So I can write this answer. The question was, let's try. Okay. The question, this is the question. He says the first part of the graph shows the motion of the skydiver from when he jumps until he reaches terminal velocity. Describe the motion of the skydiver between the t equals to 0 and t equals to 20. It's a 2-mark question. I have written this answer. Let me show you my answer, and then we will see what I can. Okay. So here we go. So speed of the skydiver is increasing from t0 second till t20 second. The rate of increase of speed has also. The acceleration is gradually. At the start, the acceleration is maximum, then the acceleration will increase. How do I know this? I know this because the body is having a free fall, and at the end, it got the terminal velocity, which means at the start the acceleration will be maximum, and then gradually the acceleration will decrease. So that's why I know that the acceleration of the body will gradually is decreasing, but the velocity, the speed is increasing in the first 20 seconds. So let's have a look at the marking scheme. The marking scheme, what does the marking scheme says? So let's see. Okay. So the acceleration or increasing speed, 1 mark for this and 1 mark for telling that the decreasing acceleration means the value of the acceleration is gradually. So this is all the 2 mark question. The marking scheme is showing on your screen. You can also okay. So the next question is, he says, explain the motion of the skydiver between t equals 0 and t equals 20 seconds in the terms of the forces acting on. You see, in the first 20 seconds, now we have to talk about the force. When he jumps, when the time is 0 and he jumps. So what happens? The force when he jumps at t equals 0 second, when he jumps, there is only one force acting on it, and that is the weight. There will be no air resistance. So the resultant force will be equal to the weight, and it will be downward, and the acceleration will be equal to the g value. But then his speed increases. When his speed increases, the air resistance experienced by that skydiver, that will increase. And the air resistance will be in the upper direction, it will be opposite to the weight. So the resultant force will be weight minus the air resistance. It means that the resultant force acting on the body, that will decrease. As he speeds up, the air resistance acting on the object, that will increase. And it means that the resultant force will decrease. It means that the acceleration of the body will decrease. So at 20 seconds, what happened? The acceleration, he has got so much speed that the acceleration, the air resistance he's experiencing, that becomes equal to its weight. When the air resistance becomes equal to the weight, the resultant force becomes 0, and then the body will start moving with the terminal velocity. The acceleration will become 0. The body will move with a constant velocity. We call that terminal velocity. Let me show you. I have written this is a 3 mark question. I have written this answer, and let's see what happens. Okay. Now, at the t equals to 0, only weight is acting on the skydiver. Acceleration will be maximum. As the speed of the skydiver increases, the air resistance acting on the skydiver will increase. Resultant force will decrease. At t equals to 20, air resistance will become equal to weight. Resultant force will become 0, acceleration will become 0, and the skydiver falls with a constant velocity. So let's check the marking scheme. What the marking scheme says. It's a 3 mark question. 1 mark for telling that initially the acceleration is due to the force of gravity or weight only, or force of gravity weight larger than the air resistance from t equals 0. Air resistance increases with the speed, and resultant force decreases, becomes 0, or force is balanced, or air resistance equals weight. So this is how the 3 marks are distributed. I hope you will be able to achieve them when you will write this answer. Okay, let's move to the next part, and the next part is on your screen. He says, using figure 1.1, determine the terminal velocity of the skydiver. On the figure 1.1, indicate any values used for your calculation. Okay, so let's go to I have done this on a paper. I will show you how I have done this, and then we will be able to do it. Okay, so here I go. This is question number 1, B part. So this is the graph which was given to us, and on that graph, I have taken 2 points. For example, I have taken this point, and the coordinates of this point are 45, 2000. I have taken this point, and the coordinates of this point are 25, 1000. And I will apply the formula for the gradient of this graph. in your mathematics, you must have studied that the gradient of the graph is m equals to y2 minus y1 divided by x2 minus x1. The gradient of the distance time graph is equals to the speed. So you can see if I will have this value, this is the y value and this is the x value. You also in mathematics call rise by run. So y2 minus y1, you see 2000 minus 1000 divided by 45 minus 25. So we will be equals to 1000 divided by 20 and it will be 50 meter per second. 50 meter per second. This is how you have to do this question. You have to mark these points which you have taken, whose coordinates you have noted on the graph, and like this green color triangle you have to make, and then you have to show your calculation for the gradient. The gradient of the distance time graph is equals to the speed of the object, and that is 50 meter per second. So let me check the marking scheme. What the marking scheme says. B part is showing on your screen. He says two different pairs of coordinates from the straight line section of the graph seen. Correct use of the coordinates in the division. The answer could be from 48 to 52. Our answer is 50, so it's good. And the range of the answer is from 58 to 50. 48 to 52 meter per second. So our answer is good, and I hope that you have understood that how we have done this question. Okay, let's move to the next question. And the next question showing on your screen, figure 2.1 shows a satellite moving at a constant speed in a circular orbit around the Earth. So in this figure, you can see here we have Earth around this. A satellite is rotating, is orbiting around the Earth. And the first question is coming on your screen. The first question, 1 mark question, he says speed is a scalar quantity, but velocity is a vector quantity. State how a scalar quantity differs from a vector quantity. The scalar quantities are completely described by their magnitude only. And when I say magnitude, I mean the size and the unit. But the vector quantities have their magnitudes to describe or a vector quantity. It has magnitude as well as direction. So the difference between the scalar and the vector quantities of the direction, the scalar quantities do not have direction. The next question is underline every vector quantity in the list. So here we have distance. Distance is a scalar. Displacement. Displacement is a vector. Then I have force. Force is a vector. Length is a scalar. Mass is a scalar. And time is also a scalar. So only there are two quantities which are vector. You can underline them, displacement and force. Then the next question is, he says, there is a resultant force acting on the satellite in the figure 2.1. Explain how the motion of the satellite shows that a resultant force is acting on it. You see, if an object is under the influence of a resultant force, there will be acceleration in the body. Now, acceleration is when there is a change in the velocity. And there can be two kinds of changes in the velocity. The magnitude of the velocity might be changing, or the direction of the velocity might be changing, or both of them might be changing. But he said that the satellite is moving at a constant, you see, he used the word constant speed. It means the magnitude of the velocity is not changing. So it means that only the direction. If that direction is changing, then it means there is a change in the velocity, and that shows that there is a resultant force. You see, the satellite is moving in a circular orbit. When you move in a circular path, every moment, after every moment, your direction needs to be changed. Then you can be in the circular orbit. Otherwise, you will be going along the tangent, and you will be no more in a circular orbit. So because the direction of the motion of the satellite is continuously changing, or the direction of the velocity of the satellite is continuously changing, so it means that the velocity is changing. It means that there is acceleration in the satellite, which means that there is a resultant force acting on the satellite. Let me show you my answer. I have written this answer, and then we can. Okay. So here we go. Scalar quantity do not have any direction. Displacement and force are the vector quantities. Direction of velocity of satellites changes at every moment. Although the magnitude of velocity is constant, change in direction is only possible if there is a resultant force acting on the satellite. Change in velocity also means that there is acceleration. Acceleration means there is resultant force acting on object. So this is how you write this answer. Let me show you the marking scheme, how the marking scheme wrote these answers, and then we can go. Question number 2 is showing on your screen. You can size it a bit. Now the problem is, okay, now you see that we can, it is a scalar, does not have a direction, displacement and force underlined, the direction of motion is changing, velocity is changing with time, or it is accelerating, which requires a resultant. I hope that you can write better sentences, but these 2 points should be included, that the direction of the motion is changing and the velocity is changing, which means acceleration is accelerating, which means when a body is accelerating, it requires a resultant force. It's a 2-mark question. Okay, let's go to the next part. State the cause of this force. The force which is providing this this resultant force is the centripetal force. And I've written this answer. Let me show you my answer, and then we can. Okay, and the question number 2C at the bottom of the page, you can see question number 2C, second part. Gravitational attraction of the Earth provide the centripetal force. The centripetal force required by the satellite to move in the orbit was provided by the gravitational attraction of the Earth. Okay, so let me check the marking scheme. Gravitational, he says the gravitational attraction of field of the Earth, 1 mark for this. Okay, so we are moving to the next question. Okay. So we are going to the next question. The question number is 3. Here you can see we have figure 3.1 shows a door, an automatic door, closer viewed from the above. So it's a top view. You must have seen these doors, and if this is the door, he has taken the camera here, and from top he's taking the view. So it's the top view of a door, and with this door we have attached a bar, which is which we do not let this door close very fastly or open very fast. You must have seen these things normally attached with the doors, so the doors do not slam against the hinge. Okay. So here you have provided the force F, the hinge or the pivot is here. So this is the force, this is the line of action of this force. It's perpendicular distance from the pivot, or we call it the moment arm, that is 0.72 meter. Another force F is acting here, and the length of the F is larger. It means the F force is larger. The length of the P force is smaller, the vector is shown. So it means this force is smaller in the magnitude. But this F force is distance, perpendicular distance from the pivot, that is this one, and it is small. So this door will rotate like this. It will open and close. When the door opens and closes, the hinge acts as a pivot. A girl opens the door by exerting a force P at the point X. Force P is perpendicular to the surface of the door. Figure 3.1 shows that point X is a distance of 0.72 meter. Along the front of the door from the hinge, the force P is 25 Newton. Calculate the moment of the force P about the hinge. So if I want to calculate the moment of this force about the hinge, and the force is given 20, this P force is 25 Newton. and its moment arm is 0.72 meters. The moment is the force multiply its moment arm, F multiply D. So I have done this on a paper. Let me show you my work, and then we go on the next. So you can see that moment of the force P is F multiplied D, 25 multiplies 0.72, and it will be 18 Newton meter. It will be 18 Newton meter, and let's check the marking scheme, what the marking scheme says, and the answer will be 18 Newton meter, and it means our answer is good. So we are done with the question number 3A first part. Okay, let's go to the next part. He says that now the question is, the moment we know the door rotates about the hinge by 90 degrees, the circumference of a circle of radius 0.72 meter is 4.5 meter. So the door rotates, and this circumference, the whole circumference means the whole circle, that is 4.5 meter. Calculate the work done on the door by the force P. So I can calculate the work done, and the circumference of the door is given, but he says that the door only rotates 90 degrees. So if the door only rotates 90 degrees, it means only 1/4 of the circumference is covered. Because the door rotates only 90 degrees, so it means that the door moves only 1/4 of the total circumference. So the distance traveled by the door is 1/4 of the 4.5 meter. So 1 divided by 4.5, that will give you the distance. The door has moved, and the force you applied is 25 Newton. So the work done is equal to 4 multiplied distance. You multiply 25 Newton with the distance traveled, that is 4.5 divided by 4. And the final answer will be 28.125 joules. I have done this on a paper. Let me show you my work. So here you can see this. And let's increase the size. Okay. So hopefully you can see the work done is equals to F multiplied distance, and that is 25 multiplied 4.5 divided by 4, and the final answer will be 28.125. 28.125 joules. So you can say 28. So hopefully you have understood this, and let's okay. So now we can go check the marking scheme. 28 joules will be the answer. So I think it's good. So now move to the next part. Okay, let's move to the next part. His question is, as the door opens, there is a force F on the door in the direction shown in the figure 3.1. Although the force F is larger than the force P, the door rotates about the hinge. Explain why. He's talking about this force. Let me show you that diagram so you can understand what we're talking about. So he says that he's talking about this force and this F force. You can see this F force is quite large, and this P is smaller. This P is trying to produce a anti-clockwise moment. This F is trying to produce a clockwise moment. He says that the force F is quite large as compared to P, but still the door rotates anti-clockwise. The door opens. Why? The simple reason which you can quickly understand is that the door is opening because the moment produced by the P is larger than the moment produced by F. That's why the door opens. That's why the door is rotating anti-clockwise, because the anti-clockwise turning effect or the anti-clockwise moment produced by the P is larger than the clockwise moment produced by the F, although F force is larger than the P force. So how come this is possible that this moment is smaller? F is larger, but as compared to P, but this moment is smaller. The straightforward reason will be It's the moment. It is the moment arm. The moment arm of the force F is smaller than the moment arm of the force P. That's why the moment produced by the force F is smaller than the moment produced by the force P. And that is the reason that the door still is opening, although the force F is larger than the force P. So I hope that you have understood. And let's move to the markings. I have written this answer. First, let's read my answer. And then we can check the marking scheme. Okay, so I have tried to write this answer, and force F is larger. Force F is larger, but its moment arm is smaller. Force P is smaller, but its moment arm is larger. I'm comparing both of them with each other. So the moment produced by the force F is smaller as compared to the moment produced by the force P. That's why the door has rotated anti-clockwise, and it has opened. So let's check the marking scheme. What the marking scheme says. Marking scheme says the question number 3, part B, moment due to the force P is greater. Distance of the X to the hinge is greater than the distance from where the force F ends. So we have discussed these 2 points. So I hope that if you write this answer, you will be able to get full 2 marks. Okay, dear students, let's move to the next question. The question is question number 4. Okay, here we go. The 3 angles of a glass prism are 45, 45, and 90 degree, as shown in the figure 4.1. So here at the point Y, a light is entering, and it makes obviously 90 degree with the surface of the glass, and it has not deviated. It has gone straight, undeviated. And when it will hit this face, the other face of the glass prism, so we have to, this is point Z, and we have to decide what happens here. He says the point Y, a ray of light of a single frequency travels in air and strikes the side of the prism at 90 degrees. The ray passes into the glass prism. Light travels more slowly in glass than in air. State what happens to the wavelength of the light in the ray as it enters the glass. See here, the speed of the light in the glass is slower. The speed of the light in the glass is smaller, slower, as compared to the speed of light in the air. So if the speed of light will decrease, the wavelength will also remember. So whatever will happen with the speed, the same thing will happen with the wavelength. So what happens to the wavelength of the light in the ray as it enters the glass? The wavelength will decrease because the speed will decrease. You don't have to write because the speed will increase. Because the speed will increase is for us only, okay? So in the answer, you only have to write that the wavelength will decrease. The next part he's asking is, state what happens to the frequency of the light in the ray as it enters the glass. You see, the frequency of the light will not change. When it enters from air into glass or from glass to air, the frequency of the wave do not change. So this was question number 1A part. I have written this answer. Let's read that, and then we can check the marking scheme as well. So here we go. So wavelength of the light will decrease, frequency of the light will remain unchanged. Okay, so let's check the marking scheme. What the marking scheme says, it decreases, it does not change. So these are the question number 4A, first part, second part. Okay, so let's move to the next part. The next part on your screen is the question number 9B part. The refractive index of the glass is 1.6. Calculate the critical angle for the light in the glass. You know, a very famous formula, 1 divided by sine C. 1 divided by sine C is equals to N, refractive index. So I will use that formula. I know the N value, and I will find out what is the value of the angle C, is the critical angle. So I have done this on a paper. Let me show you. This is showing on your screen right now. So here we go. It says that this is now showing on your screen. Let me take it out from my paperwork as well. Okay. So question number 4B, first part. 1 by sine C is equals to n. So 1 by sine C, the n value is given, that is 1.6. So sine C cross multiplied, the sine C will be equals to 1 divided by 1.6. So sine C will be equal to 0.65, 625, I mean. Take this sine to the other side, the sine will become sine inverse. So on your calculator, write shift sine 0.625 equals to. So you will get the answer 38.7 degrees, which is approximately 39. So 38.7 degrees the answer. You can approximately write it as 39 degrees. So very famous formula in the chapter of light, that 1 by sine C is equals to n. Never forget this form. So this was question number 4B, first part. Let's check the marking scheme, what the marking scheme says. So then we can move on. Okay. So marking scheme 4B, first part says that the answer will be 39 degrees. Then we got that answer. Okay, now the next part is, he says, let me show you. He says on the figure 4.1, sketch the path of the light after it strikes the side of the prism at Z and after it returns to the air. Okay. So I've done this on a paper. Let me show you my work and then we can move on. So here we go. Here we go. So you can see here I have shown that when it strikes the Z, this red color line is normal. Normal is that line which makes 90-degree angle with the surface of the glass. Then I will check what is the angle of incidence. It will be approximately 45 degrees. And I will put my D here because angle of incidence is 45, which is more than the critical angle. So it means the light will not go out here into the air, but the total internal reflection will take place. And so the light will be reflected from this point. If the angle of incidence is 45, with the help of the compass, put your protector here and mark 45 degree and then draw this blue line. So this angle of incidence and angle of reflection, they both will be equal to 45, 45. So when this blue light, I'm just showing it as blue light, when this light will reach this face, it will be making 90-degree angle with the face of the prism. So there will be no deviation. It will go straight out without any deviation. So this is how you will draw this. So let's move to the next part. And so let's check the marking scheme first of all. What the marking scheme says. We are done with question number. He says in the marking scheme, he says reflected ray at the Z and the angle of incidence, angle of reflection, they both are equal to each other. And says ray strikes vertical phase perpendicularly and undeviated in the air. So we have done the diagram, it's perfect, there's no problem in it. So let's move to the next question, sir. Okay, so the next question is on your screen. Here we go. Let me reduce the size so you can see the whole thing clearly. Okay. So the question is very simple. He says, okay, figure 5.1 shows some parts of a thermocouple thermometer that is being used to determine the temperature of a liquid. So here, this is a thermocouple. This is liquid. This is ice and water mixture. So we call it cold junction. This is called the hot junction. This is made of iron. These wires are made of copper. So he says suggest an appropriate metal material for the X, Y, and Z. You see this X is made of copper. The Z is also made of copper. The Y is made of iron. This is the cold junction. This is hot junction. And here we put a voltmeter. This is the basic diagram of the thermocouple. And sometimes this comes in the paper and you have to draw it. And here the Cambridge itself has drawn this diagram. So never forget this diagram. So X will be copper, Y will be iron, and Z will be also copper. So this is the first part. I hope you have understood. Okay, so now we are moving to the next part. And he says, question number B, first part. All types of thermometer require the measurement of a physical property that varies with the temperature in order to obtain a value for the temperature. State the physical property of the thermocouple thermometer. That is, see, in the thermocouple thermometer, what happens whenever there is a temperature difference between the cold junction and the hot junction, EMF is induced or voltage is induced in those copper and iron wires, and that can be measured with the voltmeter. So the EMF induced when there is a temperature difference between the hot junction and the cold junction. EMF induced, let me show you my answer and then we check the marking scheme also. Okay, so copper, X is copper, Y is iron, Z is copper. Question number 5B, first part. EMF induced when there is a temperature difference between hot junction and the cold junction. So let me show you the marking scheme. The marking scheme says X, Y, and Z to be 2 or 3 different metals. Output thermoelectric is thermoelectric, electromotive force or EMF or voltage. This is the property which is used to measure the temperature. So let's go back and we can the next question. He says, discuss what is meant by the term linearity when applied to a thermocouple thermometer. Linearity of a scale normally means that there will be equal change in the property for equal change in temperature. Or in other words, you can see the change in the property is directly proportional to the change in the temperature. If this is so, then we say that the thermocouple thermometer, its scale is linear. So the change in the property is directly proportional to the change in the temperature. So we will say that this is the graph is that the thermometer is linear. The scale is linear. I have written this answer. So linearity means that EMF induced is always directly proportional to the temperature difference between hot junction and the cold junction. Okay, the EMF induced is directly proportional to the temperature difference between the hot junction and the cold junction. Okay, so let's move. This is marking scheme. We will see later. Let's move to the next part. What's the next part is? He says, the question is, he says, state 2 advantages of a thermocouple thermometer over a liquid in glass thermometers. So the advantage of thermocouple thermometer is a very, very famous question. It has came many times in the paper where you have to tell what are the advantages of the thermocouple thermometer. You see the thermocouple thermometer, it has, it is robust. And you can take it anywhere, and it can take temperature, remote temperature. But the remote temperature that you don't have to go near the object. You can make probes, and that probes, because that those are biased copper and iron, you can make it them longer. That will be like a probe, and you can take the reading at a 2 or 3 or 4 feet distance from the object. That's the remote reading. Another very important advantage of the thermocouple thermometer is its range is very vast. It can measure very low temperatures. It can measure very high temperatures. Another very important advantage of the thermocouple thermometer is that thermocouple thermometer, it can measure very rapidly changing temperatures. Another very good important is because it shows the change in the temperature by induced EMF. You can use a data logger and then feed that data logger or connect that data logger with the computer. And when you will do this, then the very rapidly changing temperature, all of that temperature will be recorded on the computer. So you can connect the thermocouple thermometer directly to a computer through a data logger, and you will get a perfect cooling curve or a heating curve. And it's robust, it's easy to use. And these are the few, I have written this also. Here you only have to write 2 advantages. I just told you a lot of the advantages. So you only have to write just two advantages. So so he says, it can measure rapidly changing temperature, one benefit. It can measure very high and very low temperatures. So its range, the range of this thermometer is quite large. So these are the advantages of using thermocouple thermometer. Let me show you the marking scheme, because in the marking scheme he has also listed a lot of advantages. Okay, so on your screen, and it's very important. This is a 2-mark question. I just want to show you the advantage which they have written in the marking scheme. Let's see here. Any 2 from means you just have to write 2. Measure rapidly varying temperatures, quick response, small heat capacity, electric output. Output can be fed directly into a computer. Measure high temperature. It means large range, robust, and precise location, remote reading. So these are the few, the few of the benefits or advantages of using a thermometer. It's a very famous question. It always comes of 2 marks, where you have to write that why a thermocouple thermometer is better thermometer. So let's move to the next question. And that is question number 6. He says, question number 6 is, okay. It's a 2-mark question. Let me exercise. When electricity is transmitted over large distances, a transformer is used to increase the voltage before transmission. A second transformer is used at the destination to decrease the voltage to usual mains value. Sketch a label diagram to show the structure of a transformer that is used to increase the voltage. So they are talking about a step-up transformer which increases the voltage. In the step-up transformer, the step-down and step-up transformer, they look alike, but there is one difference. In the step-up transformer, the number of turns on the secondary coil are more than the number of turns in the primary coil. In the step-up transformer, the number of turns on the secondary coil should be more than the number of turns in the primary coil. So let me show you. I have done this. I made the diagram. Let me show you my figure. Okay. So you can see the diagram is showing on your screen. Here we have shown a frame of iron core. And on one side, the left side of this, I have wound a wire. And this is connected with an alternating power supply. And I call this primary coil. This is the input side of the transformer. And this is called the primary coil. Its turns are, number of turns on the coil are called NP. The voltage is called VP and the current is called IP. On the other side, I have also made a coil. It is not connected with any source of electricity. This is called a secondary coil. You can see the number of turns of the secondary coil are clearly more than the number of turns in the primary coil. And the number of turns are represented at NS. The voltage in the secondary side, which will be induced, that is called the VS, and the current induced, that is called the IP. So it's a step-up transformer. You can see that the number of turns in the secondary are more than the number of turns in the primary. So that's why it will increase the output voltage. The output voltage will be more than the input voltage. The next question, which is showing on your screen, let me show you. He says, if you look at the marking scheme for the figure, he says iron core and two coils wrapped around the core, input and output clear, and more turns on the secondary coil. There should be more turns on the secondary coil. One mark for this. So I hope that we have done this. So this is question number 6, A part. Let's move to the next part. It says, okay. So the next part on your screen, it says that describe the principle of operation of the transformer. Describe the principle of operation of a transformer, and it's a 3-mark question. Very, very famous and very important question. So I don't have a diagram here. And then the next question is explain one advantage of transmitting electricity at high voltage, a 2-mark question, also very famous. I have written this answer, so let me show you. Okay. So so try to understand. In the primary coil, this primary coil, I have connected alternating supply. So when the alternating current will come in this coil, you see, due to the presence of the current, the primary coil will become an electromagnet. So when the current will flow through the primary coil, it will become an electromagnet. And because you have provided here the alternating current, the direction of the alternating current is all the time changing. It flows, for example, if it flows to the left, in the next moment it will flow to the right. So because you have connected the alternating current in the primary coil, the direction of that current will change. It changes continuously. So what will happen? The electromagnet which will be formed on the primary coil, its polarity will change. So for example, at one moment, this lower side will be north, and in the next moment, the upper side will be north. Then this side will be north, then upper side will be north. So you see, when this lower side is north, the electromagnetic lines of this primary coil, this electromagnet, through the iron core, they pass through the secondary coil. So they pass through the secondary coil and they come back. So when this side will become north, they will come out of here, magnetic lines, to the iron core. They will pass to the secondary coil and they go here. And if this is north, then they will come like this. So the magnetic lines of the electromagnet found on the primary coil, they are passing to the secondary coil through the iron core. So because the magnetic lines which are passing through the secondary coil, they are changing in direction and their magnitude is also changing. So when there is a changing magnetic flux passing through the secondary coil, EMF is used in them. When the magnetic lines, are going in this direction, the EMF induced here, it has a different direction. When the magnetic lines are going in this direction, then the EMF induced has a different direction. So you see, in the secondary coil, due to the changing magnetic flux passing through the secondary coil, and an EMF is induced in the secondary coil, and that EMF is also alternating. So let me read my answer. I was just trying to explain it to you. Alternating current is provided to the primary coil. Primary coil becomes electromagnet. Polarity of this electromagnet is changing due to change in direction of the current which you introduced into the primary. Through iron core, the magnetic flux of this electromagnet on the primary coil passes through secondary coil. Due to changing magnetic flux, EMF is induced in the secondary coil. Due to change in direction of the magnetic flux, current will induce in secondary coil. The current induced in the secondary coil is alternating. So this was question number 6, B part. And then the next question is, why when we transmit the electricity, why we transmit it at a very high voltage? You see, when by using a transformer, you increase the voltage. You make it very high. The voltage is increased. The current will decrease. And the power loss in the transmission lines is given by the formula P is equal to I square R. So when the value of the voltage will be higher, the value of the I will decrease. When the value of the I will decrease, see here in this formula P is equal to I square R. When I will decrease, the P value will decrease. It means that the power loss in the transmission lines that will decrease. When voltage is increased, current decreases. Power loss in transmission lines, P equals to I square R. If I will decrease, means current will decrease, power loss in the transmission lines will also. So this is why we do this, to reduce the power loss in the transmission line. So this was question number 6, and it's C part. Let's check the marking scheme for both of them, and then we move on. So here we go. This is question number 6, and B part. Magnetic field, mention one number. Alternating current, AC current produces magnetic field that varies. 1 mark for this. And core channels, magnetic field to secondary coil and electromagnetic field. Yeah, when there is a changing magnetic field passing through a coil and EMF is induced in that coil, this process is called electromagnetic. This process is called electromagnetic induction. So due to the electromagnetic induction, the EMF is induced in the secondary coil. Question number 6C part, he says it's a 2-mark question. Less energy transfer to the thermal energy in the wires because smaller current for a given power. So I hope that you have understood. And let's move to the next question. It's a very famous, this C part is very famous, and the operation of the transformer, the principle by which the transformer operates, is also a very important question. So my dear students, let's move to the next question. The next question is on your screen. Nuclear fission is a reaction that occurs in the sun and other stars. Explain what is meant by the nuclear fusion. In the nuclear fusion, you see the smaller nuclei. They come close to each other and they fuse into each other and they make larger nucleus. And during this process, a lot of heat energy or thermal energy or maybe light energy is given out. This is called the nuclear fission, and I have written this statement, very famous question, and on your screen, I think it's showing. Let me increase the size. And he says, smaller nuclei fuse into each other to make a larger nucleus. During this process, lot of energy is given out. So you see, this is called the nuclear fusion. The smaller nucleus, they come close to each other, they fuse into each other, and they make a larger nucleus. The parent nucleus are smaller, nuclei are smaller, but the daughter nucleus which is formed is larger. So let's check the marking scheme as well. But the marking scheme says, the marking scheme says, joining together of smaller nuclei. For example, you can say hydrogen nuclei, releasing a large amount of energy. So this is how the 2 marks are distributed. Okay, let's move to the next part, next question, I think. Okay, so he says, describe the nuclear fusion reaction that takes place on the sun. So on the sun, you see what happens. We have hydrogen, it's isotopes of hydrogens. So hydrogen nucleus come close to each other and they fuse into each other and they make a larger nucleus of helium. And with this, lot of heat and light is given out. So this is what is happening on the sun. So let me read my answer and then we can go on. So, so here we go. So this is question number 7B part. Smaller nuclei of hydrogen fuse into each other and make nucleus of the helium. During this process, lot of energy is given out. So this is the nuclear reaction which is happening on the sun. So let me check the marking scheme. He says hydrogen reacts to produce helium. So this is question number 7, and this B part, this marking scheme we have checked. Okay. So the next part is, what's the next part? A star forms when temperature of a large cloud of gas in space increases as the cloud collapses inward. Straight energy transfer that occurs as the cloud collapses. Very few students have studied this chapter because this is not in the physics matter. And I can tell you the answer. The answer is there. Okay. So let's be precise. He says, so what will happen with the energy? Question is very simple. When cloud collapses, gravitational potential energy will convert to kinetic energy to internal energy and light energy. Very simple answer. He's talking about the stars. Okay. So let's see what the marking scheme has to say, and then we will move on. Okay. So the gravitational, he says the gravitational potential energy to internal energy, kinetic energy, gravitational potential energy to kinetic energy to internal energy and light. So this is the 2 marks. And okay, then we have the next question. Okay, he says very straightforward question, easy to answer. The temperature increases starts at a nuclear fusion reaction. Explain why the temperature of the star eventually reaches a steady value. So when the temperature of a body becomes constant, although it's like a furnace, it's producing heat and heat and heat, but its temperature is constant. Why? Because the rate of loss of heat and the rate of production of the heat, they have become equal to each other. So in other simple words, you can say that the heat which is produced by the process of fusion and the heat lost by the infrared radiation, they both have become equal to each other. So that's why the temperature of the star eventually becomes a steady value, or it becomes constant, because the heat produced and the heat lost, they are equal to each other. So let me read my answer, then we can go on. So here we go, and it says energy is lost by infrared radiation. Loss of energy and energy produced by fusion reaction are equal. That's why the temperature is constant. So let me check the marking scheme, and that's it. This marking scheme. Okay. So the marking scheme says the energy emitted by the infrared or electromagnetic radiation, energy loss is equal to balancing energy from fusion reaction. So whatever the energy is being produced by the fusion reaction, that energy is lost by the infrared radiation. So that's why the temperature has become steady, has become constant. So let me go to the paper first and confirm. So now then the B part starts. So my dear students, today in this video we have only done section A of 2020, October-November 2020 2-1 paper. We have only solved section A. The section A, B of this paper I have solved in another video, and you can find that video in my YouTube channel. That is in the we have paper 2 zone 1 section B. This is the playlist, you can find it there. And if this paper is helpful, this video is helpful, and you have learned something out of this, kindly don't forget to subscribe to my channel, and also recommend this to your class fellows, to your friends, and so that everybody can benefit from the efforts which I'm trying to make to provide this paper practice to everybody without any fee or any cost. So everybody get a good, I can say, scorpion in past paper practice. So I hope that it's beneficial for you. So thank you very much, everybody, and have a good day, and God bless you all.